In this video, I'll show you the internal differences between the Nissan Patrol gearboxes from the TD 4.2 engine and the ZD 3.0 engine variants. Both transmissions carry the same model number, RS5R50A, but don't let that fool you. They differ in much more than just the power takeoff or PTO port. As we'll see later, the cast iron housings and the control mechanisms are completely different designs, even though they are interchangeable to some extent. In this photo, you can see the transmission from the 4.2 engine shown with its specific control setup. Looking at the main cross-section, you can see that this 5-speed gearbox uses ball and roller bearings. This makes assembly much easier compared to designs with tapered roller bearings that require precise preload adjustment. While this transmission is considered incredibly strong, it does have its drawbacks. The cast iron housing and bell housing add about 20 kilograms, that's around 44 pounds, to its weight, and the 5th gear spline is known to be a bit of a weak point. After counting every single tooth on the gear sets, I discovered that the 4.2 gearbox differs from the 3.0 version only in the 3rd gear ratio. This is a crucial detail because the original PTO unit only works with the 4.2 ratios. Why? Because the power takeoff draws drive directly from the lower 3rd gear cog. The 3rd gear ratio in the 3.0 is 1.488, which is closer to the 2nd gear's 2.456 than the 4.2's ratio of 1.422. These ratios were changed because the 3.0 engine has less low-end torque compared to the 4.2. Here is a comparison of the transmission housings for the 4.2 and the 3.0 engines. In this photo, you can see the left side of the 4.2 case. It features the specific cover plate for the power takeoff unit. Now let's look at the left side of the 3.0 transmission housing. As you can see, there is no access port for the power takeoff here. The 4.2 case from the clutch side. The bolt mounting points and dowel pins are the same as in the 3.0 case, but in the 4.2, where there are no contact surfaces, there are recesses thinning the wall. The 3.0 case from the clutch side. The entire surface is machined and there are no recesses on this side. The 4.2 case from the transfer case side also has recesses in the walls. It features larger access holes and an upper center M12 bolt thread, which causes some issues for this transmission housing, but I'll get into that later. The 3.0 case from the transfer case side. The entire surface is machined and there are no recesses on this side. Notice the upper center bolt thread. It's an M8, not an M12 like in the 4.2 case. The 4.2 case from the right side. The oil filler plug is clearly visible here. The same applies to the 3.0 case, except that the reinforcement ribbing is different. The 4.2 case, an inside view of the left side. The 3.0 case, an inside view of the left side. Notice the two fairly high ribs at the bottom. In its natural position, the oil won't drain out completely by gravity alone. You can also see that the wall recesses are on the inside. This provides a larger oil capacity, although it requires more surface machining on the outside. The 4.2 case, an inside view of the right side. The 3.0, an inside view of the right side. Let's take a closer look at this upper center M12 thread. This is a major design flaw. The large hole in the thin bridge above the bearing bore causes the housing to crack. This structural weakness can cause housing cracking. This area in the 3.0 has been improved. Here we have a hole with an M8 thread instead. After a discussion on the off-road forums and following Vandal's advice, I bought some Chester molecular glue. The M12 hole near the crack won't be used for bolting. I'm only focused on a good seal because the other 11 M12 bolts and the heavy-duty transfer case adapter handle the structural strength. Besides, this area mainly deals with compression forces between the transmission case and the adapter. I'll only install a short stud here for sealing purposes. In this photo, you can see the drying process after degreasing. The chemicals I used for the repair: Chester C36 molecular composite for bonding the bolt, and Chester B00 for penetrating the crack. These industrial-grade compounds ensure a long-lasting seal and structural integrity in the damaged area. In another 4.2 case, there were no cracks in the housing. Now, a quick test fit of the 3.0 gear selector on the 4.2 housing. In the next video, I'll show you exactly what needs to be done and why to make them work together. So, the 3.0 shifter assembly doesn't quite fit the 4.2 case. Luckily, the main dowel pins line up perfectly. Here is the left side. And here is the right side. And clutch side view. View of the upper right side from the transfer case with no mounting point for the bolt. And here on the 3.0 there is a casting boss in the housing that creates a spot for the bolt to screw in. Comparison of the gear selector assemblies. On the left from the 4.2 case, on the right from the 3.0 case. The 3.0 case assembly is actually better. It's lower, lighter, 7.5 kilos, or approximately 16.5 pounds compared to 8.5 kilos or 18.7 pounds, less complex, and simply a newer design. The mounting location for the gear shifter socket on the 4.2 case, and the mounting location for the gear shifter socket on the 3.0 case. The gear shifter tips and sockets from the 4.2 case and the 3.0 case. We can see that the tip from the 4.2 case is thicker. The gear shifter from the 3.0 case fits the 4.2 case. Here is the 3.0 case gear shifter with the tip and the socket. And here is the 4.2 case gear shifter with the tip and the socket. And here, for comparison, is the gear shifter from another 2.8 case, which has the same plastic tip as the 4.2 case, meaning it is larger. The 2.8 case and the 4.2 case or 3.0 case sockets are practically the same. However, this shifter from the 2.8 case is 7mm, approximately 0.28 inches, too long to work in the 3.0 case or 4.2 case socket. Here it is after shortening for use in the 4.2 case. Why all these complications? The gear shifter from the 2.8 case is easily available in Europe. Here next to it lies the 4.2 case tip. Continuing the comparison between the 4.2 case and the 3.0 case selectors. As I said before, the 4.2 case selector is significantly taller, so it needs more space in the body tunnel. The 4.2 case selector and the 3.0 case selector. The interior of the gear shifter selector on the 4.2 case. The interior of the gear shifter selector on the 3.0 case. The selector assembly from the bottom. On the right, the 4.2 case, and on the left, the 3.0 case. You can see here that besides the height of the 4.2 case gear shifter socket, which is higher in the 4.2 case, this socket is also positioned further forward compared to the placement of the 3.0 case gear shifter. A close-up view of the gear shift forks from the 4.2 case. You can see the details of this mechanism here. And the same view for the 3.0 case selector. Comparison of the selector mounting points to the gearbox housing. At the top of the photo, the 4.2 case, 6 side mounting points. At the bottom of the photo, the 3.0 case, 5 side mounting points. Comparison of the front sections of the selector assemblies. At the top of the photo, the 3.0 case. At the bottom of the photo, the 4.2 case. Comparison of the aluminum rear housing for the 4.2 case and the 3.0 case, which acts as the adapter between the gearbox and the transfer case. Here, we can see the upper middle hole for an M12 bolt, approximately 0.47 inches, in the 4.2 case, and for an M8 bolt, approximately 0.31 inches, in the 3.0 case. It is quite significant that the aluminum rear housing for the 4.2 case of the Nissan Patrol Y60 or GQ includes mounting points for the transfer case linkage. This means that on the 3.0 case aluminum housing, we won't have these mounts. The 3.0 was only available in the later Y61 or GU model where the transfer case control is direct without any additional linkages. Aluminum rear housings, a view from the inside. In order to install the gear selector from the 3.0 case on the 4.2 case, you need to grind down these additional ribs in the 4.2 case aluminum rear housing. The mounting points for the chassis crossmember at the bottom are, of course, the same. Further comparisons between the 4.2 case and the 3.0 case. The cast iron front cover. The mounting points are the same, although the casting itself differs with different ribbing in the lower section. These same front covers for the 4.2 case and the 3.0 case differ from the inside in their oil drain channels. Therefore, it's better to match the 4.2 case cover with the 4.2 case housing, and similarly, match the 3.0 case cover with the 3.0 case housing. The fifth gear top sprocket from the 4.2 case and the 3.0 case. On the 3.0 case sprocket, there are additional cutouts or oil channels. Those sprockets on the other side looks the same. The rear bearing plate for the 4.2 case and the 3.0 case, it's practically the same in both cases. The input shaft for the 4.2 case and the 3.0 case. On the 4.2 case shaft, you can see two solid rings. The main shaft. Besides the third gear ratio, it differs by a special additional set of thrust rings for the rear bearing in the 4.2 case. Here is the set of thrust rings for the rear bearing in the 4.2 case. The countershaft differs by the third gear bottom sprocket ratio. Comparison of the third gear top sprockets. On the left from the 4.2 case, on the right from the 3.0 case. This photo shows the differences in the gear mesh. On the left from the 4.2 case, on the right from the 3.0 case. The reverse idler gear has two additional thrust washers in the 4.2 case on the left with a total thickness of 5 mm, approximately 0.2 inches. The 3.0 case does not have these washers. Therefore, when swapping the 3.0 case for the 4.2 case to gain PTO access, you must install one additional 5 mm, 0.2 inch reverse idler thrust washer there. Here is the fifth gear mesh in the 3.0 case. And here is the fifth gear spline, which is known to be a bit of a weak point. It tends to fail under heavy use. As you can see, there is enough space for it to be a bit longer as the width of the fifth gear allows for it. This gearbox has a 4-speed version. Most likely the fifth gear was added later and the spline could not be deep enough. However, it is too short for heavier loads. In the last Patrol Y61 or GU4, it was lengthened. In Australia, repair kits are available including the main shaft and the gear sprocket. Summary. We have two types of gearboxes for the Nissan Patrol with cast iron housings. The GQ 4.2 case has the option to connect a PTO. The GU 3.0 case and GU 4.2 case do not have the PTO mounting option. The GQ 4.2 case and GU 3.0 case gearboxes differ in their third gear ratios. All internal mechanisms are bolt-on interchangeable. The gear selectors in these gearboxes are different, but after some modifications, they are also interchangeable, as I've shown in another video. In the GU4, the fifth gear spline has been enlarged. In the next video, I will describe how to adapt a rear differential lock to the front axle.